one last sample of maps of the use of web portals, and this sample is this one. You will probably see with Prof. Raval you will use probably ArcGIS and QGIS for the projects, for some works, for some exercise. There is a website of which is let's say created and put online by Esri, which is the producer of ArcGIS. The goal is always the same, is the one that I'm talking with you today for, is to give an idea on how maps can be of help in different topics. In this case, this website has this name, Cool Maps. So cool, nice, interesting. First one is, here you can see there are 12 or 13 different type of maps. We'll go through very, very quickly. So COVID view map. And this is mapping cases and deaths across the globe using data from Johns Hopkins. And here, as you can see, it is, you can move. I haven't yet seen this map, but it is moving from one country to the other. And of course, if you do something like this and you click here or somewhere, you can choose the country and you can have the information. And here you have the list of the countries. I don't see India. I don't know why. Anyway, I don't know if waiting some time is collecting more information. Doesn't seem. For example, there is not Italy, but there is Switzerland, France, and so on. Anyway, go through these maps. COVID. Big Apple bicycle map, homeless shelter, world of shipping, here probably with the ports, number of tons, and so on. Historic maps from 2000 to 2011 were shipping container traffic. So whenever you choose a year and you choose a place, you probably will have the number of tons from that port. I don't know if they give more information or if it's only this. Usually there is some interaction. Let's go back. Let's go back, sorry, here. So world of shipping, crime time. Crime time is probably, I think I remember it's from Brooklyn and, no, San Francisco area. So we will go back there. Urban growth in San Francisco, visualizing the World Bank indicators. This is interesting if you're doing jobs. There are lots of different indicators and maps in 3D, mapping the happiest countries, hurricane tracker, migration trends, New York City collision. I remember it reports the crossing of the roads where there is a high number of collision, which involves bike, which involves pedestrian, and which involves car. Should appear on the map. Will take some time probably. I don't know why it's not happening. I don't know if it's my network that is very low or slow, or if it's usually it was happening. It was appearing very quickly. Let's go back to my events this week. vision, zero, dashboard, traffic, and so on, crime trends, and TikTok. Mapper of time, I don't know what it is, I don't care. I want to go to the crime in San Francisco, which is probably this one. You can choose the different type of crimes. You can choose the day of the week. And you see, depending on the, for example, assault, you have only the assault, and you see days of the week and time of the day. So we are talking Monday, 9 o'clock, noon, 3 p.m., 6 p.m., 9 p.m., the number of the areas of San Francisco where there are this kind for every day, for every time of the day. All the crimes or only single crimes. I think it's interesting because, for example, this is impacting a lot the search of houses. So if you're looking for a house, this is an interesting information. So you have kids and so on, and you have a map saying which are the safest areas. And if you are living somewhere, if you're living in a certain area, you know, for example, you're living here, you know that on Friday, at a certain hour of the day, it's better not to go out because there are 40 crimes at 60, 70. You can see for any hour of the day, the number of crimes, and this will help you in deciding when to go out or not for going to the shop and buying food and so on. And lots of other, also these kind of maps are very easy to be implemented. Let's see what they do with the Bank of the World indicators. I remember probably there is population. This is a very nice way to represent information. Population, all the countries, export, foreign investment, and the major country here. So I think it's something nice to see, but also interesting to get ideas on how things can be shown to the public. This is a public way to demonstrate life expectancy, and this is life expectancy. So you can stop and work on this and see that 83 years in Hong Kong and 82 in Somalia, in Singapore, and I don't know if it's possible. Oh yeah, and it's possible to move up to 48 years in Lesotho. So almost the half expectancy of life than in Hong Kong. I think go through this website and take a look to these maps, always with the goal, with the idea of trying to understand what you could propose, what you could invent, or what could be your project for this course. Because as you probably know, in the second week, so next week, you will be working on a project, and the project will be done through using the tools that you are learning in this first week, and the ideas regarding the project are up to you. So you have to decide what you want to do as a project. And depending on your experience, depending on your background, depending on the data you think you can find, and so on. To give you a last support on this. discussing about the projects. I don't know if you have already seen this, but this very short video was linked. It was linked to the form that you filled at the beginning, while in order, because we asked you which kind of experience and competencies in software and so on. If you didn't went through, this is a sample. This is a brief video, 3 minutes video, describing the project that your colleagues have done in a previous winter school, which is probably 2016, I think. And so, analysis of the factor related to crime in Ahmedabad city. So they collected data, they defined indicators, they created maps, and they prepared this kind of presentation. Okay, this is showing different words categorized by extent. This is the same project. So you have 2 or 3 different maps per project. Second project, real estate, housing sector in Ahmedabad, describing the areas, describing the city, and a few maps detailed of the type of apartment, of, I don't know, whatever else, trends. I don't understand which kind of trends. Site selection and ranking for transfer station, stations in Ahmedabad where there is transfer with they are ranked, so they describe which kind of ranking they are doing on the transfer station, and then some maps regarding the. Unfortunately, for example, this is something I will ask you not to do. So a map like this without a title, Ahmedabad input dataset. I don't care which dataset they have been using to create this kind of map. They need to explain this map. They need to say which year, which attributes they are using, what they do, and so on. Otherwise, this is not self-explaining. All the maps need to be self-explaining. This is self-explaining. I don't have the dimension to go here. Other project, site suitability for a 5-star hotel project in Ahmedabad, all the analysis, all the description, and so on, where to build a new 5-star hotel in Ahmedabad. Final output map showing suitable site for Ahmedabad web positioning, existing hotels, assessing a level public transportation service Surat. Okay, bus, okay, stops of the public transportation, roads, people living, business, how many companies, how many industries, and a proposal, if I remember correctly, for new stops or something like that. I don't remember this one. To obtain the mining location in India of a different, or the study the mining cluster in India, to analyze the effect in the area, to derive the change in the area. Okay, yes, depending on the existence of mining. So the project is collecting data, searching for the data, geocode the data. The project is projecting the project, so stopping a few hours, saying, look, I'm interested in public transportation, I'm interested in hotels, I'm interested in housing, what could I do? I could do something like this, I could do, so some brainstorming activity together with us, and then creation of the project, description of the project, collection of the data, location intelligence. This is an analysis of demography and urbanization in, I think, in Gujarat area. And I think there is another one. So maps, square meters, demography, land under agriculture, and so on, population, urban population, people living in the countryside, and so on. No, this is probably the last. Okay, so this is only another support. Sorry, I think I should share with you also this link. Share, copy. As recalled maps, CEPT winter school projects. And so you will find this link in your. Okay. So this is enough, I think, regarding the potentiality and possible idea and suggestions on type of different application of the GIS, of the geotechnologies, and so on. So now I would like to go on with talking about geopositioning technologies. So we will talk about GPS, we will talk about indoor positioning, we will talk about different experiences. I will show you some application related to positioning of people, of assets, of tracks, and so on. So, first of all, an introduction. You probably know, all of you probably know or have heard about GPS. In the last, let's say, 5 years, the GPS has become very popular and very cheap. And being very cheap is now inserted almost everywhere. 5 years ago, the cars with navigation system were 5%. Now the cars with navigation system on board are 80%. 5 years ago, 7 years ago, the number of cell phones with GPS were 5%, now are 100%. So any cell phone that you buy has the GPS in. Right now, the GPS is very, very cheap. We're talking about $1, $2 to have the chip with the GPS. So you are building a new washing machine, you insert the GPS. You are building something that needs to be installed on top of the roof. Let's say some solar photovoltaic panel. Very often in photovoltaic panel, there is the GPS, because if they are stealing the photovoltaic panel, in some way you are able to locate it. I installed the photovoltaic on the roof, and I also have the battery that is during the day storing energy, so that in the evening I can use this energy in my house without spending money. And the battery has a GPS, and if they steal this battery and they attach it somewhere, it will tell everybody where, it will tell me, and not only to me, where the battery has been installed. So the GPS is almost anywhere. What is a GPS? The GPS is a chip that receives, doesn't send any information. It is only receiving information from a let's say 24 satellites on which are let's say approximately 20,000 kilometers from the Earth. So there are satellites. They are the first GPS satellites has been let's say produced and sent in the space by the American US Defense Department, and they were supporting the am I sharing my screen? Yes.
Yes, sir.
Yeah. And they were supporting the military, the army of the US while abroad. As I told you, the GPS which is inside your phone is receiving data from these satellites. So these satellites are sending continuously one signal. I will not go deeply in technical details, which kind of signal, what does this signal contains. I'm not interested. What I'm interested in is that you are somewhere on the Earth. If the GPS, which is on your smartphone, receives at least 3 signals from 3 different satellites, using an algorithm, it's able to calculate its position on the Earth. So I repeat once more, the GPS on your smartphone is receiving signal from satellites, and using this signal is triangulating his position, and so is able to calculate the coordinates of your smartphone. Receiving is not sending anything. So up to 15 years ago, the signal that this satellite were sending to the Earth was modified by the US Defense because they wanted the GPS to give the right position and precise position only to the US Army people. So they modified the signal they were sending, and only the GPS built for the defense were able to understand and use these changes in the signal and calculate the correct position, while all the other GPS were giving a position which was, let's say, in a area of 200-300 meters. So there was an average error of 100 meters. It could give you the right position, but with a very low percentage of probability. So if you were using that GPS to travel in the desert of Africa, it was very useful because while you are traveling in a desert and you have to reach a certain village, even if the position is wrong 200 meters, you don't care because it will help you in reaching the right position. While if you are looking for an electric pipeline under the earth, where you have the right map with the right position, and you use the GPS, and the position of your GPS is wrong 200 meters, you risk that you are drilling in the wrong place. So why did the American defense, let's say, deteriorated the signal? Because the GPS can also be inserted not only in your smartphone, but can be inserted inside a bomb that can be launched. And using the GPS, which is inside the bomb, you can say, I want to reach that building with that coordinates. And if the GPS, which is in the bomb, is very precise, the bomb will reach exactly that building. So in order not to give disadvantage to the enemy, the Defense Department modified the signal so that you know that if you insert the GPS in a bomb, it could do a mistake of 200-300 meters. So you will not use this technology to guide your bombs if you are not in the US, if you are not from the US Army. Then what happened? That it was found a way to fix the problem, so anyone, also the people not from the US Department, were able to get a precise position. And so approximately 15 years ago, they decided to liberalize the signal. And so anyone has a good signal, and anyone, also you, have a GPS, which is able to calculate your position with some centimeters, decimeters, meters of error, depending on where you are. If you are in a forest, your GPS has over the smartphone, there are the trees, and the more the leaf of the trees are, let's say, are covering the horizon, and the worst it is the position that your GPS is calculating, because the satellites are sending the signal, but the signal is modified by the leaves, and so your GPS is calculating the position with an error that could be meters, or could be 10 meters, or could be 100 meters, depending on how many leaves you have on your head. If you are in a city which has, or in a part of your city with very narrow roads and very high buildings, if you watch the sky, you will see a very little part of the sky. And in the same way, only few satellites. So you will not see all the satellites you could see if you are in an open square. But you will see, your GPS will see only the satellites of the part of the sky that is up on your head. And if the road is narrow and the buildings are high, you will see a very little part of the horizon and the sky. And so you will not have the precision that you will have if you are walking in a wide open area. So it could happen, you can experience very often that when you are in this kind of areas, for example, with the car, in the street, very narrow with huge building, the GPS of your car can give a wrong position. So you're not in this, it doesn't say that you are in this street, but you are in the street which is 20 meters on your left or on your right. And this is due to this problem. In that moment, the GPS of your car doesn't see enough satellite, or it sees enough satellites, but the signal is, let's say, reflected by the wall of the buildings, and so doesn't reach directly the GPS, but there is a satellite. The signal arrives because it reflects, the building reflects to your GPS in your car, and this reflection creates a problem. So if they are asking, or if you want to know how much precision has the GPS of your cell phone, you have to go somewhere open, wide open area, open the GPS, open Google Map, zoom on Google Map or on another map that you uploaded on your smartphone, and see if the position of the GPS is closed or exactly the one of the map that you have in the background. And then you can measure the differences. So it's I am in the street corner, but I am not in this side of the road. I am on the other side, and the GPS gives you the wrong side. It means you have 3, 4, 5 meters error. It's in the exact position where I am. It means that in that area, your GPS at 0 or almost 0, because centimeters, millimeters, it's not a problem, error. So it's not easy to say what is the precision of a GPS, because it is depending on the position, on the area, on the hour of the week, of the day of the week, and so on. So as you can see here, your GPS receives signal and is triangulating. The more the signal is, the more the area is open, and the more precision is the position that is calculated. So these are this is a satellite. This is the GPS card, an old GPS card. We were buying this kind of cards. We were inserting the PC or somewhere else, and then the PC could be used in order to calculate the position. This is a Garmin sample. So this is a GPS with the antenna, with some buttons and some functionality, and a screen with the map. In the first GPS has no map. They were only giving on the display latitude and longitude, and then you had a paper map, and you were looking for that latitude and longitude, and you knew where you were in that moment. This was how I was traveling in 1985, 86, 89. I was traveling for work, but sometimes also for holidays in Africa, and we were using a GPS with a display and with the coordinates. And we had paper maps because there was no digital maps, and we were looking using latitude and longitude, our position. We are reaching there. We have to go northeast. We have to go northwest. And I remember clearly that the first GPS we bought was as big as, let's say, a portable computer, a laptop like this one, and was $3,000 US, while now, as I told you, it costs $1, the chip, and you don't need to buy it, because if you have the smartphone and you go to Africa, you know exactly where you are. And so $3,000, $1, this is what has happened. Then what are companies doing? They need to track fleets of vehicles. They need to track the airplanes. They need to track the boats. They need to track people, very important people. Usually have in their bag or in their backpack a little GPS. As I told you, the GPS is receiving and is calculating the position. So if you insert a GPS in the backpack of a VIP, you will never know where he is. Only the GPS will know where he is. So what has been developed are objects like, for example, this one, which are composed by a GPS and a modem, a GSM modem. So these two objects together, the GPS calculate the position, and the modem with the SIM, a smartphone with a SIM, sends the information to a certain website. In this way, the GPS helps in controlling people, in controlling vehicles, in controlling airplanes. The GPS continuously calculates the position, and some other object connected to GPS sends the information somewhere. This object can be a smartphone, can be a modem, can be a radio modem, because in certain areas or while flying the aeroplane, there is no GSM signal, so the telephone is not working. So how do they send their position? They send their position using radio frequencies. I want to... Do you have questions on this? On how the GPS is working? If you don't, I want to show you 2 or 3 websites using GPS. This is very famous. I think that you probably know it. This is Flight Radar. It's open to anyone, and it gives worldwide position of all the airplanes flying in real time. So let's go to India. These are the airplanes now flying in India, all of them. And as you can see, they are moving. So let's wait a little bit. You can see the map. The airplanes are moving. So this one are the airplane landing in Ahmedabad airport. As you can see, it's moving. The more you zoom, I don't know if it's landing or if it's taking off. And if I click on this, it says it is the one that's going from Ahmedabad to Pune, schedule 15:25, arrival 16:40. It is leaving. It is taking off now because you see it starts from the parking lot, and will take off and will fly away. And all of them, these are all the airplanes. And each of them with information. This is Chandigarh, I don't know, to Ahmedabad. This is Hong Kong to Abu Dhabi. So this is passing and not. And the position is real time calculated by the GPS. So inside this airplane, there is a GPS, which is receiving information from the satellite. He's calculating the position and using radio channel is sending the position to the website, to the Flight Radar 24 website. It's not this, but it will send to a certain web server that then, through the Flight Radar 24, but also from other services, can be used to show the real-time position of this airplane. It's interesting. If you register, if you log in to this website, so if you create an account and register, I remember there is also the function okay, I think it's always the same. It took off, so it went at the end and is now taking off. So it's passing in this moment. It is the one going to Pune that we saw before. You see, it went to the end. And if you register, there is a function that you can choose the airplane and see what the pilot sees. So you will have a view using Google Maps and using Google whatever, and you can see while he's taking off, you can see, he knows, this website knows at which height in this moment the airplane is, so it can create the view, from the same height of Google. So you can have Google, you say, okay, now I am 1,000 meters, now I am 2,000 meters, I am over the hospital, I am here, I am there, and so you can see what the pilot sees. It's interesting. It's useful if you are looking for waiting someone and you want to see where the airplane is, when you have to start from home to go to the airport to pick him up, or if you're doing analysis, or it's interesting to see that now it's 12 o'clock, so it is 6 o'clock in the morning here, and it is 3 o'clock in the morning here. So you can see that on top of Los Angeles, there are very few airplanes. If you connect now in 10 hours, tomorrow morning, your time, you will see that it's overcrowded, like it is probably in this moment London, because London is one of the most frequented airport in Europe, and now it's 12 o'clock, so there are lots of flights from London, from Paris, and so on. So you can see during the day, during the night, where they are moving. You can understand which are the main roads going from Europe to US. So you can see there are roads that they are following one each other and so on. This is a website. Why I'm showing this? Because this is possible only because the GPS is giving the position and is calculating continuously the position. And some device is sending this position somewhere. The same is with this website. The same is with this website, but instead of showing airplanes, it shows boats. So these are all the boats that are compelled to use GPS. So if you have a little boat that you use to go fishing, you don't have to install GPS, but if you are working with the boat, you need to have installed a GPS, because the Navy wants to control where you're going, what you're doing. And each of these different boats have the GPS, and you can, a minute ago, this boat, which is going from RTD to, which is going from, I don't know. Not easy to understand where she's going. This one is going to Bhavnagar, India, and is coming from Puerto Natales, Colombia. So this boat is coming from Colombia, is going to India somewhere, and here you have the position. If the boats are close to the, let's say, to the Earth, the position is updated quite frequently. If they are in the middle of the ocean, as for the transmission they use satellite, they don't update very frequently. 10 minutes ago via satellite, 15 minutes ago, 18 minutes ago. So it's not every second, 4 hours ago, because the satellite transmission is expensive, so they don't continuously update the database as the airplane that are using radio, or as the boat which is close to the coast, which are using GSM or radio. So take a look in the Gibraltar a minute ago, 2 minutes ago. So the frequency is more accurate. Okay, if you don't have any question, I can. Do you have any question on this kind of things? Of course, also here, the problem is not creating the web GIS application, because a map show a symbol on a map is very easy, as you have seen yesterday with Google Maps. You upload an Excel file with the coordinates and they go there. So imagine there is an Excel file with all the list of all the airplanes, and there is someone that every minute or every 5 seconds is changing the coordinates. You do a little cycle that reads the Excel file every 5 seconds, and the position is uploaded on Google Maps every 5 seconds. Finished. As you can see here, every time I remember to highlight this, I do it. Google. So here on the bottom right. So the background map is Google. So as I told you, functionally, this is very easy. You need to have the information. You need to have some website giving real-time information of the boat, of the airplane, and later you will see of the tracks. Any question? Boats on the Mississippi, 20 minutes ago. Okay, unfortunately, any question? I go back and I stop recording and sharing. I'll be back in 10 minutes.